This is question 5 from homework number 2. This is the integral test homework. And they give you this very messy looking series here. I think if you start listing terms, it's going to be very open to question about what it might possibly do. You really should check. Always do the nth term test first, because the easiest way for them to trick you on a series and make you do a bunch of unnecessary work is to give you a series whose terms don't approach 0. Okay, this is the same thing as n over e to the n. You want to look at the limit as n approaches infinity. You can probably just kind of think about this. We have a linear term here being divided by an exponential term. That exponential term is going to grow more quickly. The terms will approach 0. Technically, this is L'Hopital's rule. And you would substitute infinity in here, and you would get infinity over infinity, and you would take the derivative, and you would try again, and you get 1 over e to the n. And now when you substitute infinity in there, you get 1 over infinity, which is going to approach 0, okay? So the nth term test tells us that this has the possibility to converge. Doesn't mean it will, but it has the possibility, all right? So that's really something you should always check first before going into these problems, okay? If you don't, you will get burned somewhere, and you'll probably waste a lot of time doing it, okay? It's one of the easiest ways to trick people on calculus tests. All right, so the idea of the integral test is, and again, keep in mind, these are just, they're just going to ask you about series being convergent or divergent, or possibly ask you how you can tell. They're all going to be mixed together, okay? So obviously, this is an integral test section. That's probably going to be how you're going to approach this question, but you just need to be able to recognize, hey, this doesn't look anything like a geometric series. It doesn't look like the harmonic series, doesn't look like a p series, doesn't look like any of the other things we've talked about. Hey, but I think I can take the integral of this. And if you think you can take the integral, then you maybe have something you can use the integral test for. So remember, the idea is to relate it to the related function, okay? This is not a continuous function, it's just a list of numbers. But we can match it up with the related function x e to the negative x dx, and we can take the integral between 1 and infinity, okay? And this is going to be an improper integral, okay? Unfortunately, the derivative of the inside function is -1, which is not x. That product there is not very convenient. This is going to require integration by parts, so they're going to be real good at combining together everything you know on the AP exam. This is one of those cases. So you've got a u, and you've got your dv here. I would do an x and your e to the negative x. Du would be 1. V would be the antiderivative, which would be negative e to the negative x, okay? And remember, you take u times v, which is negative x e to the negative x, minus the integral of v times du, which would be this, technically dx, okay? You got minus and negative there. I would probably get rid of that and make it a plus, just make your life a little bit easier. And in the end, if we end up with an antiderivative of negative x e to the negative x. And by the way, we're going to have to evaluate this. Negative exponents are terrible for evaluating limits. So I would write that as negative x over e to the x, okay? And then the integral of this is going to be negative e to the negative x. I would probably write that as minus 1 over e to the positive x, okay? And we need to evaluate this between 1 and infinity. Again, you don't usually evaluate with an infinity. You normally put in some other variable there. And we'll say we're going to take the limit of this as b approaches infinity, would be basically kind of the standard here, okay? So now we actually have to try to evaluate this, and this is getting a little bit messy here. All right, so if we substitute here, you're going to have negative b over e to the b minus 1 over e to the b minus, and then you're substituting 1 in here. That's going to be negative 1 over e minus, oh, that's interesting. When you put 1 in here, you're going to get another 1 over e. By the way, I need to be careful. That's negative 1 over e. Okay? And we're really taking the limit of this as b approaches infinity. Okay? Now, Technically, you've got an infinity over infinity. Again, a lot of you may see that this denominator grows faster than that numerator. If you see that, you can probably see that this is going to approach 0. Really, you should be using L'Hopital's rule here to evaluate that limit, okay? If you did that, use L'Hopital's rule, of course, you could take the limit as b approaches infinity of the derivative of the top over the derivative of the bottom, and then you could see that this would be approaching 1 over infinity, which is going to approach 0, okay? And again, be careful about, I'm being kind of lazy here, AP people would like you to copy this limit statement again. Anyway, the point is, this is going to approach 0. Negative 1 over infinity, that's going to approach 0. And you're subtracting negative 2 over e, and so it looks like this is going to approach 2 over e. Now, be careful here. Honestly, and I didn't check that very carefully, so you may want to check my work on that. I'm not asking you to find the integral here. I'm just asking you to find if it converges or diverges, okay? So even if you made a mistake on that last step, the point here is this will converge, okay? That is not the sum, okay? If you remember my earlier video, when we draw those rectangles, they either stick out above the curve or below the curve. The integral is not going to be the same thing as the actual sum, okay? They're not going to ask you to find these sums in most cases unless it's something special like geometric or maybe a telescoping series, okay? So that's all that's going on here. This is a convergent series by the integral test.